Hey guys, it's Desmond, and today we're going to be transforming the sine function. First, let's take a look at some of the terms. First, we have period, which is the length of a cycle. Next, we have axis of curve. This is the value of the halfway point between the maximum and the minimum values. Lastly, we have amplitude. This is the distance between the axis of curve to the maximum or the minimum point. And don't worry, I'll explain these a bit later. Now we need to realize and recognize the equation that we have. This is a sine function. F of x is equal to a sine bracket x minus c bracket plus d. Now a is equal to a stretch or compression, c is equal to a horizontal translation also known as a phase shift, and d is equal to a vertical translation. Now all of these will depend if you move left or right, stretch or compress, depending on the values that it gives, whether it's plus or minus. Now let's take a look at a sine graph example. This is your basic sine graph with the equation that I just showed you. So as you can see, the period would be 360 because one period is going up and it's going down and it's coming back to the middle. The axis of curve in this case would be 0 because if you were to cut this graph down the middle completely, halfway perfectly both sides, you'll have 0. And the amplitude is just from the axis of curve, which was 0, to the maximum point, or the minimum point, which in this case would be 1 unit. Now you need to know these key points which are crucial to solving and transforming the sine function. Now you can see these 0, 0, 90 and 1, 180 and 0, 270 and negative 1, 360 and 0. Now, these numbers we're going to need to remember and work with later on. Now, it's time for our example and for me to show you how to actually transform the sine graph with a given equation. Now, this is a graph we'll be using as demonstration. It's the same graph we just saw before, it's just a little longer because of the way it was printed and how the graph was put together. It still has the same period, axis of curve, and amplitude, and all the same points are on this graph. Now we need to transform it with a given equation. Oh look, a given equation. Now we have this equation, which is sine bracket theta plus 30 bracket minus 1. Alright, we're going to need to do some math. That means we need to calculate it. Now to calculate this and find new points to plot and draw the graph, we're going to do some calculations for x and y. First we'll take x. So what you're going to need to do is take the x point of one of the points from our 5 key points that we talked about earlier and subtract this 30 value, which is c in this equation. And that'll give you your new point. And for y, you pretty much do the same thing. You take the y from the key point and you subtract the d, which is 1 in this case. And of course it'll be different if you have a positive, a negative, or a positive and negative, but you could figure that out, I hope. Now if you look, 0 minus 30, negative 30. 0 minus 1 is negative 1. And this is one point right here. Remember, the 0 and 0 were one of the key points that we talked about, and these of course are our x and our y's. See? I knew it. The key point. Now, these are all the calculations that needed to be done. I won't bore you too much, trust me. The x and the y, and this is pretty much how they go. As you can see, we took the point from the key point and the value from our equation and calculated all of them. We took the y key point from our key points and subtracted r1 from our equation to give us new values. So one of the points on this graph would be 60 and 0. And 240 and negative 2, and that's just 2 of them. And our new points would be these. So now what we need to do is graph it. So we had our old points, and this is the new graph if we were to plot all the new points. Our old equation put into new points. So as you can see, the old graph is dotted in blue with the 5 key points. And our new graph is dotted in green with our new key points. As you can see, it was translated 30 units, well, 30 degrees to the left and 1 unit down. So if you take a look at this point, for example, it was 30 to the left and 1 down. Hey look, we're at our new point. And you can see it was with all of them. So all you needed to do was plot every single 5 points of these and then draw a line between them all. And look at that. You've just graphed a new sine function. Enjoy your new skill, everybody. Bye for now.